Welcome back, everybody. So today we're going to go through differential calculus, more specifically the gradient at a given point, using just a purely sort of analytical sort of graphing approach. So let's have a quick look at question 1. So this is sort of the beginning of differential calculus, where we need to simply understand what is the difference between f of 0 and f prime of 0. So if we think of f of x being a function of x, then f of x is actually like the y value. So we plug an x value into the function and the output will be y. So here, when we're asked for part A to find f of 0, it's basically asking us to plug 0 into the function, and what is the output in terms of y. So we have a graph here. We can see that if we substitute 0, which is actually the origin point, into the graph, the output is 4 on the y-axis. This has a coordinate then 0, 4. Okay, so f of 0 then is in fact 4. In other words, the y value when x is 0. So the part B of this question states though f prime of 0. Right, so f prime of 0. So the difference here is this is the gradient function. So it's asking us what is the gradient at 0. So we go back to 0 again and we go up to the graph and it wants to know the gradient at this point. So we can see that it's a linear line. That means a straight line. So what is the gradient at this point? Well, in order to solve this, we're actually going to need to use another point on the graph because it is a straight line. And we know from other parts of the course that in order to find the gradient of a curve at any point, we can do y2 minus y1 over x2 minus x1. That is if it's a straight line. Later on, we're going to be using the power rule and we're going to be using different techniques to find gradient. But here we're just given the graph and we're not told the function. We just know it's a straight line. So what we'll do is we'll use this point down here. So it says that when x is 4, y is 0. So we can use the 2 points that I'm about to highlight in orange, so 0, 4 and 4, 0, to help us find the gradient. Some of you may have already guessed what it is, but for those of you who are not sure, I'll just use the formula. So the gradient between these 2 points is y2 minus y1, so we can do 4 minus 0 over x2 minus x1, which is 0 minus 4, which results in 4 over negative 4, which is minus 1. So the gradient of this straight line is actually minus 1. Okay, so it's linear, so it's minus 1 throughout its whole journey. So therefore, we simply say that the gradient at 0 at this point is negative 1. Okay, now let's move on to the next example. Use the graph below to find. Now we've just seen this in the first question here. This is asking us to find the gradient at 2. So we go to 2 on the x-axis, and we can see that they've put a dotted line in here for us. So it's asking us to find the gradient at this point. Now we have another straight line. We call this like a tangent to the curve. So so I'm going to use m for gradient. So what is the gradient at this point? We're going to use the same technique that we just did in the previous question, whereby we know one point on the curve is 4, 5, and we just need another point. Therefore, we can use the same gradient expression, which is y2 minus y1 over x2 minus x1, and this will help us find the gradient of this straight line. And we can see that this 1 is sort of sticking out here. This has a coordinate 0, 1. Therefore, when x is 0, y is 1. Now we can use the 2 points here to help us find the gradient of this straight line. So we're going to do y2 minus y1 over x2 minus x1. So we've got 4 over 4, which is 1. So the gradient of this straight line is 1. So going back to the question, if we see this expression f prime of 2, is asking us here, the main thing is to understand that this is asking us what is the gradient when x is equal to 2 of the function. Or another way of wording is if we drew a tangent to the curve at x equals 2, what is the gradient of that tangent? And we've just sort of figured that out in the process above, that it would be 1. So again, these are just some core sort of fundamentals, some sort of key concepts that are going to help you as we move on through this unit. Okay, this question, I've jumped a question, we're moving through an exercise. So question 4 states, for the graph y equals f of x, alongside the derivative function is given. Okay, so this time what they've done is they've just given us an expression for gradient. Now at this point in time, you don't need to worry about where that's come from. Just understand that this is an expression that will tell us the gradient at any given point. So if we want to find the gradient on the curve at sort of -2, for example, we would just substitute -2 into this expression, right? If we want to find the gradient at 0, okay, remember you're always doing a tangent to the curve, we will substitute 0 into this. So that's how the gradient function works basically. So they've given us a gradient function and it says find and interpret this here. So f prime of -2. So as I just said a moment ago, that means find the gradient at -2, or what is the gradient at -2. So we've got a derivative function and it's asking us to find the gradient at -2. So I'm going to go ahead and draw like a tangent to the curve here, and it's basically asking us what is the gradient at this point. So I'm going to start my answer here, that the gradient at -2 is equal to, now this time we don't really have any coordinates to use, so we can't use y2 minus y1 over x2 minus x1. So what am I going to use? Well, we're going to use the expression that they gave us above. So it was given above that f prime of x is equal to 2x plus 1. So if we're asking us for f prime of -2, we're just going to substitute -2 into this expression, and we'll end up with -4 plus 1, which is -3. So the gradient at the point when x equals -2 is -3. So m equals -3. Now I'm using m because it's commonly used, m for gradient, but really you could use b, you could use another letter, but at this point I'm just using m because that's what I've taught in the past. Okay, and part 2 of this question says, what is the gradient when x is equal to 0? So this expression is asking us what is the gradient when x is equal to 0. So in other words, we're going to go down here. So when x is equal to 0, which I've just circled in orange, it wants us to know the gradient on the curve at that point. So if you could imagine we're sort of drawing a tangent, what is the gradient of this tangent? What is the gradient of this straight line? Now we don't need to do anything else other than substitute 0 into the gradient function. So again, the gradient function is this value. So when we substitute 0 into this expression, we would simply get 2 times 0 is 0 plus 1. Okay, so the gradient at that point is 1. It says copy the graph and include the information in A. I've pretty much drawn this information on the graph, so I'll just end the video there. Good luck.